radioactive substances decay over time, and the mass m in grams for a particular radioactive substance d days after the beginning of an experiment is shown in the table below. So this is the table that has been given to us, in which the days and the mass are given. So we know on day 0 the mass of the radioactive substance was 120 grams, and as the number of days increased, the mass decreased here. So after 90 days the mass was reduced to 76.36 grams. And we need to find out if this relationship is modeled by the function md, which is equal to a into 10 raised to power bd, which of the following could be the values of a and b. So we know the value of m, so I'll just start by writing the function here md, which will be equal to a into 10 raised to power of bd, and the value of m and d can be taken from the table, and we'll substitute the values of a, b, c and d and find out which one is the right answer. So let's take this option here. When the number of days is 30, m is, so we know m is 103.21 when d is 30. So let's go to all the options here. Let's go to the option A and find out whether we find the right answer or not. So first, since we have to find 10 raised to power bd, first let's find the bd for all the 4 options a, b, c and d, and then we'll find the mass. So bd for option A would be, it would be 30 into 0.0145, so that would be 0.435. For option B it would be minus 0.435 because the value of B is similar. Let's go to the option C. BD should be 30 into 0.0022, so that would be 0.066, and for option D it would be minus 0.066 because the value of B is same in both option C and D. There is just a negative sign in option D, that's why we have got a negative sign here. Now let's find the value of 10 raised to power BD here for all the 4 options. So for the first option it would be 10 raised to power 0.435, so this would be 2.72, and since this is a negative here, so it would be 1 upon 10 raised to power bd, so we have to divide 1 divided by 2.72, so we're left out with 0.36. Let's go to the option C here. So it would be 10 raised to power 0.066, so it would be 1.16, and in option D, since we have a negative, so we'll have to divide 1 by 1.16, so that would be 0.86. Now all we have got to do is to multiply with A here, because that is the last element left in M, which implies we'll find out the mass now for all the 4 options. So this should be 12 into 2.72, this is 32.64. Now the value that we have is 103.21 when the number of days are 30, so we can eliminate option A here. Let's go to the option B. It would be 12 into 0.36, that is 4.32, that is way less, and hence we can eliminate option B as well. Let's go to the option C. Now A is 120 and we have to multiply it by 1.16, so that would be 139.2. Here the mass is actually increasing and not decreasing, hence we can eliminate option C directly. Let's go to the option D. So this would be 120 into 0.86, that is exactly 103.2. Hence, option D is the correct answer.